Okay, in today's lab, we're going to show you the procedure for heat treating metals. I have three types of metal here. They're all considered a drill rod, which is a high carbon steel, and three different diameters. On my key here, basics of drill rod, W1 is a water hardening drill rod, and it happens to be 3/4 of an inch in diameter. That's why the three different sizes. We have an oil hardening, which is 5/8. Here's our 5/8. And then we have an air hardening 1/2 inch. So I can determine which one is which by the size. What we're going to do is heat these pieces of metal up to approximately 1625 degrees C. That's going to be a compromise. Each one of these different hardnesses or drill rods require a different heat. But what I'm doing is I'm taking a kind of a compromise between all of them because we don't want to do each one individually. To heat those up, we have a big furnace here that we can put our parts in. Fairly decent sized furnace for a lab environment. And what we have is we will put our parts in here, which you've probably seen already. We have several parts already mounted in the furnace. The furnace is not on, so I can put my hand in here. In the lab, we would actually heat up the furnace to 1625 degrees Fahrenheit. And it takes about an hour and a half to get up to temperature. I would load the furnace with our parts. Typically, it's about a 1/2 hour per inch of thickness is how long the part has to soak once it gets up to temperature. Our workpieces will actually glow bright red when they're up to temperature. Okay, so let's say we've had this in here for an hour now, and it's been up to temperature, our parts are glowing red. What we have to do is we have to quench these parts. So we're going to take them out of the furnace and put them in whatever it's supposed to be. The first one, the big diameter, 3/4, is going to go, it's a water hardening. So I've got a bucket of water here, and what I would do is I'll drop the part in the water. The 5/8 diameter is an oil hardening. I'm going to drop it in this bucket of oil. Well, I've got a little can inside the bucket. I want to make sure I drop it in there so I can fish it out without too much trouble. And finally, the air hardening one, the small diameter one, will go up on top of the furnace. And we'll let that just cool naturally in the air here. Okay, so our hour has gone by, and what I would have to do is I would have to put on some safety equipment. I've got some sleeves that I would wear. I'm not going to wear them now because the furnace is not on. I'm just showing you how this would work. Also, I would need a pair of gloves. This furnace, when I open it, will be very, very hot. The temperature coming out of here is enough to burn me without any trouble at all, possibly even catch my clothes on fire if I didn't have the protective gear. And I also want to protect my face. So I have a shield that I would wear. And this would keep the heat off my face. Now, again, I'm not going to need the safety equipment because I do not have the furnace on. But in the lab, you would come in here, you would have to wear all the safety gear. All right, so we know our part is up to temperature. It's been sitting for about an hour. And I'm going to unlock the furnace. And what I generally do is let the furnace breathe for a second. Because if I open it all the way up, it's going to scald me. It's going to be very, very hot. So I let a little heat out. And then I'll open it up. And we said that this is the water hardening, the 3/4 inch diameter. So I pick it out and I drop it in the water. Okay. Then I have an oil hardening one. I pull it out and I put it in my bucket there. And finally my air hardening one. So I take this out and set it up on top of here. Okay, then I will close the furnace again and lock it back up. I have several specimens in there for different lab sections, so we want to make sure they're always ready to go. Okay, now I've retrieved all my parts from the water, oil, and air hardening. They've cooled down sufficiently. And they have a scale on them. You can see this black surface. It's a scale. It happens, it's oxidation when you're heat treating. And all three of them have this scale. I need to remove that scale before I can actually check the hardness. So I come over here to my belt sander, turn it on, and all I have to do is just kind of clean it up a little bit. That'll give me a nice surface to work with. See, it's nice and shiny. If I don't remove the scale, I'm going to get a false reading on like. Oh yeah. And that's all I have to do to remove the scale. Just knock some of that off there and get a nice surface area. Okay, now we've had our parts in the furnace for an hour. We got them hot, we quenched them, we took the scale off of the parts, and now we're going to recheck the hardness. A couple labs ago you did a hardness test with Rockwell, Brinell, and the micro hardness tester. Now we're going to use the Rockwell tester again on these same parts that you measured 2 weeks ago. Actually, I have some examples of some of the scale, the flakes that came off of the part. This flakes off, it's oxidation. We needed to clean that up. Now this is the air hardening one, and I'll put it back in our Rockwell tester. We're going to use the Rockwell C scale, which is the outer scale. And if you remember, we bring both these needles up to the set point, up by 0. So I'm putting my minor load on. When I push this bar here, it's going to release 150 kilograms of load for our major load, and we'll see what readings we have. Originally this was about a 10 to 12 Rockwell. After heat treating and then removing the scale, we now have about a 53 Rockwell. C scale, the outer scale, the black scale, about a 53. So we increased from 10 to 53 5 times. We really seen a lot of hardness in this part. Now that hardness sometimes can be a problem. A bearing surface, we need it hard so it doesn't wear. But if you have something like a camshaft that has to flex a little bit, we're going to have to draw this back. So we would put it back in the furnace at a reduced temperature for a shorter period of time, and it would draw it back a little bit. 55 may be too much hardness. We may only want a 40. So we bring it all the way up, then we reduce it back by reheating at a lower temperature.